Okay. So in the last class we have discussed about a like this. We have draw and diagram like this. Okay. Here what we are mean to say. So these are the inputs. So these x1, x2, x3, xn are our input data. Okay. So w1 and w2 and w3, wn these are the weight. Okay. So and here z. So z this means bias. Okay, you can call this bias. Some value will be added with this. So this is called bias. And after applying bias, we have to apply activation function. So activation function is just type equation. Okay. So we'll apply to this output. Okay. And finally we'll get the final output. Okay. So let us consider some nodes. Okay. So nodes we will consider and we will consider them as a human being. Okay. So this the value is 0.5 and here the value will be 0.2, 0.5 and 0.4. Okay. So after applying W1 and W2, okay, we'll apply the weights. So we'll get some value. We'll store in this brain. Okay, so just you consider this is the brain, this is the brain, this is the brain, this is the brain. So basically these are neurons. Okay, so but I'm considering it as a different brains. Okay, in here. So we'll multiply with w1 these inputs and we will store here. Okay, so how to store the value? So we'll just consider. Okay, first value is 0.5. So we'll multiply with w1. Then 0.2 into W2. Okay, so in this figure, you are seeing here that we need to add some bias. Okay, so we have to add some bias. Okay, so we'll add some bias. Okay, in 0.5. So the W1 value we are considering as a 0.3. Okay, so W1 value is 0.3. W2 value is like 0.1. 0.5 you just consider. Okay, 0. Okay, okay, 0.5 you just consider. Okay, this is 0.7 actually. Okay, 0.7. Okay, and we'll add some bias value is b value is we will consider it as a 0.1. So this value will be given. Okay, 0.1. So we'll multiply this all this. We'll multiply this two, multiply this, and we'll add with this 0.1. So 0.15 plus 0.35 plus 0.1. So the value will be 0.6. So what is that value? So this is basically this one. Okay, the summation. Okay, this is we also call this as a Z also we called. Okay, so summation of weight and inputs. Okay, so multiplication the summation of, so formula will be W I N input for, let's say, input plus bias. Okay, this is I for input, W for weight, so this will be called as Z. Okay, so this is the value of Z. Okay, so after getting the Z value, so we need to apply some activation function. Okay, okay, we need to apply some activation function. Okay, so before going into activation function, so you need to know what is activation function. Okay, so I'll tell you about the activation function. Okay, just wait. So what is activation function? So basically, activation function, the definition will be an activation function is a mathematical function. Okay, is a mathematical function applied applied Am I audible now? So there is some error in our internet connection, so that's why I got disconnected. Okay. So basically an activation function is a mathematical function that function applied to the output of the neuron. Okay. So basically this this is the Z value. So this is the output of the neuron. So basically we have two layers. Okay, so you can have many multiple layers of neurons. Okay, so basically this is kind of a network. Okay, this is kind of a network. Okay, so you can have multiple neurons. Okay, so in here three layers are there. So okay, so basically this is uh, basically a connection of all the neurons. So you just consider this node as neurons. Okay, so basically in neural network, this first layer, so in here the input will be there, so this is called input layer. Okay, IP layer, or in here the calculation, some calculation will be done. So this is the sigmoid function, this is the z we calculated just now. Then here we will add some bias, and after that we will perform some activation function. After that we will get a value, so that will be the output value. Okay, output layer. So this is called hidden layer. So the main calculation will be in this hidden layer. Okay, so now just come back to the topic. So I'll discuss about this. So this is a type of neural network. Okay, I'll discuss about it later. So an activation function is nothing but a mathematical function that will apply to the output of the neuron. So this is our output. So what is the output? Z is the output. So the value will be 0.6. Okay. So basically there are different types of function is there. Okay. Activation function is there. Okay. So I'll tell you. So what are those? So basically there are two types. Okay. One is linear activation function. Okay. So basically this is kind of a straight line kind of function. Okay. Y is equal to X. Okay. So this is basically a linear function. Okay. And one types of is there is non-linear activation function. Okay. Activation function. Okay. So this is some, you can call this, this is denoted by S shape. Okay. I'll explain what is S shape. Okay. So what are the linear activation function? So there are lots of linear activation functions are there. So basically one of the linear activation function that I will tell you. And one another is there, RELU. Okay. So this is called a rectified linear unit. Okay. Function. Okay, lots of actually functions are there. So I'll tell some of the activation function. Okay. So most basic one I will tell you. Okay, so first one I will tell you about the linear function. Okay, linear activation function. Okay, activation function. Okay, so what is this? So this is linear. So this will do nothing. So in here we are doing just linear thing, na? So this is nothing but Fp is equal to A plus V. Okay, V means Z, Wi, Xi. So basically these are the inputs of the multiplication of input and weight, that is the summation, and we will add with A. What is A? So A is nothing but its bias. So basically we can say that this thing is called linear. This will call known as a linear activation function. Okay. So this will, the graph will be like this. Okay. So 1, 2, 1, 2. So the graph will be like this. So this will be linear. Okay. So now there will be second type of function is there. So this is called Heaviside function. Okay, Heaviside step function. So what is that? So in here the function will be either the value of 1 or 0. So the value of this output will be either 1 or 0. So if V greater than equal to 0, so what is V? I'll tell you. Okay. So V will be some, so A will be some threshold. Okay. Threshold. Okay. Okay. Threshold. So if the threshold value is greater than this value is greater than A, Okay, so basically if it is greater than 0, then we will tell it is a 1. Okay, so basically if it is the value is 0.6, we will consider the f of v will be, it will be 1. Or if it is less than 0, let's say minus 0.5, something like that, so f of v will be 0. Okay, so the graph will be like this. So if the value is 1, then directly if it is between 0 to 1, okay, 0.6 is like here, okay, so it will be 1. So if the value is less than 1, less than 0, then we will directly know as a, we will declare as a 0. Okay, so this is called Heaviside step function. So one of the famous activation function is known as sigmoid function. Okay, this is the most used. Okay, sigmoid function. Okay, so this is a non-linear function. Okay, so non-linear function. So in here in this graph, so the line will go linearly. Okay, but in sigmoid function the graph will be like a curved one. Okay, basically S shape. Okay, so what is that S shape? So it will be like this. Okay, so before going to that, so we'll discuss, so what is sigmoid function? So sigmoid function is a formula 1 plus 1 plus e to the power v. So what is v? So is v is nothing but distinct. Okay, distinct. Okay, you can declare this by z v. Okay, so in here we are declaring it is a v. Okay, so v. So in here we just declare as a v. Okay, this is v actually. Don't confuse if this is v. Okay, so in here sigmoid function will put 1 plus 1 plus e to the power minus 6. Okay, 0.6. So this will give some value. Okay, just calculate this and we will put it in the graph. Okay, so not only one value will be there, so there will be lots of value. So because we have to in this neuron, we are just calculating for this first two one. So for the second two, you just calculate. Okay, in here some value will be there. Okay, so you can calculate these things. Okay, after calculating, so we'll get some a graph. Okay, the graph will be like this. Okay, this is kind of a S. Okay, so excuse me a minute. Okay, Okay, so this will be the graph will be like S. Okay, this can be S. Okay, so or you can write this because 0.6 value is there, no? So you can write it like this. Just forget this one. So in this case, our value is, let's say, 0.6. Okay, so the graph will be like this. Okay, so the maximum value will be 1, or minimum value might be -1. Okay, so this is for this is called non-zero centered function. Okay, okay, so this is a type of sigmoid function. Okay, now next we'll go to ReLU. Okay, so what is ReLU? Okay, before going to ReLU, we will discuss about the 10H. Okay, so what is this 10H is different from the previous one, non-linear. Is a non-linear function only. So in here, so the graph will be like S shape only. Okay, so 10H. Okay, so in 10H, so value will be between 1 minus 1 and 1 minus 1. In the previous case, we did not took care of the minus 1. Minus 1 we did not take care in here. Okay, so the value will be, so basically it will not come down from 0. Okay, the output value might be negative, but the input will always take it as a positive. Okay, so in here the graph will be like this. Okay, this is also called a S graph. Okay, this is standard function. Now we'll discuss about ReLU. So basically we'll mostly use sigmoid function and ReLU. Okay, this is the one. So this two activation function will be most used. Okay, so this is rectified linear unit. So the how the graph will represent here. So basically value will be 1, 2, 3, 4. Here 1, 2, 3, 4, 5. Okay, so it will start from the x value will be start from 1 to 3. Okay, so if the value is greater than 0, okay, if the function will be like this fx x, okay, if x is equal to fx is greater than equal to 0, 0 if x less than equal to 0. So what this means, so if the, let's say, value is 1, okay, then the output will be also 1. The value is 2, output will also be 2. But if it is a less than less than 0, that is mean negative value. Okay, 0.1. So directly this will come as a straight line. Okay, so the value will be always 0. Always value will be 0 if x less than equal to less than 0. If x greater than equal to 0, then the value will be straight line. Okay, so this is called rectified linear unit. How to remember this? So basically, if the function value is, so input is, let's say input x is positive value. So in this case, we got the value 0.6. In this case, 0.6. So we will get a value like in here somewhere. Okay, 0.6. Okay, in here some. But if we get a value like say 0.1 minus 0.1, so the output will be 0. So y will be 0. In this case, output will be like 0.6. Okay, because we have, sorry, if we got 0.6, then output will be 0.6. But in case of 0.1, output will be 0. It will make the output as 0. Okay, so the graph will be like this. If it is greater than 0, this is the value of 0, then this will increase, and this will be the 0 if the value is less than 0. Okay. If the value of x is 0, then we'll directly, if the value of x is less than 0, then we'll directly tell us this, the output will be 0. Okay. So you might get confused about this. So activation function. So I'll go through an example. Okay. So that will be clear. So in this case, okay, in this case, in the previous case, okay, so we got the value as 0.6. Okay, 0.6 we get the value. Okay, so now we have to apply the activation function. Which activation function we can use? So we can use either any of one of these. Okay, we can use sigmoid function. So if we use sigmoid function, so what will be the value of output? So y will be 1 plus 1 plus e to the power minus z. Okay, z value is 0.6. So it will be like 1 plus 1 plus e to the power 0.6. Okay, so some y value will be there. Okay, so let's say if we consider ReLU. Okay, ReLU. So what will be the value then? If we don't consider sigmoid function, if we consider ReLU, so 0.6. So what is that? So it is greater than 0. Greater than 0. So what will be the value of our output? So it will be in the similar way we have given here 0.6. Okay. Okay. So if 0.6 is there, we can put it like here. Okay. In here some the 0.6 will be there. So this is for only two neurons we have calculated. Okay, only two neurons we have calculated. In here only two neurons we have calculated, but it will be multiple neurons. Okay, so you will get lots of value. Okay, so let's say 0.6 you get, then you will get like 2.6 somewhere. So it will make a straight line. Okay, from this function. Okay, so that's why it is called ReLU is called rectified linear unit. So it will be a linear function. Okay, so you will get a linear graph. But in case of sigmoid function, if you calculate the value, let's say for 0.6 you will get, let's say another value you will get, let's say 0.8. Just consider for other two neurons. Then from 0.10. So you will get a graph like this. Okay, from these values. Okay, 0 points. These will be some value x, y, z. These will be the some values. Okay, so you will get a graph like this. Okay, from this output. Okay, so this graph is nothing but we are putting the outputs in a graph. So if we put the graph of a output using sigmoid function, the shape of the graph will be like a S. it will be like a S. Okay, but if we use ReLU, so it will be like a straight line. Okay, this will be like a straight line here. Okay, so and this you can use tanh. Okay, so these are the some activation function. Okay, so this is fine. So now we'll go to a type of neural network. Okay, in the last class I have discussed about different type of neural network. So one of the neural network is feed forward network or neural network. Okay, so if it is network, I am saying this is means neural network. Okay, so in here, so some input neuron will be there. So these are called input neuron. Okay, in here we will put some data. We'll put some data XYZ. Okay, so it will, these are the input layers. So that's why we will call this as an input layer, because in this neuron we will put all the data. Okay, so it is not only three. If three neurons are there, that is mean three rows are there, X, Y, Z. These are some data, 0 0.6, 0 0.5, 0 0.8, 0 0.6, 0 0.8, 0 0.9. Okay, some data are there. So basically, if three rows are there, so basically we will consider as a three neurons. Okay, so there might be multiple neurons. So I am just considering three rows. Okay, so in here you will get some. We have to put it some through some calculation layer. Okay, that is called hidden layer. So we have to do some calculation. These calculations are going on na sigmoid function, and this v weight into input we are calculating, this v we are calculating. Okay, so these things will be done in hidden layer. Okay, these are the hidden layer. Okay, so we'll have all the connection. Okay, all the nodes are connected with each other. It will be go like this. Okay, okay, these are the hidden layer. Hidden layer. Okay, in hidden layer. Next, what we will get. So after calculation, so there might be more hidden layers might be there. Okay, so if you want to do more calculation, then you can add more hidden layer. Okay, this is one hidden layer, you can add one more layer. Okay, then this will be like this. Okay, 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 and finally we will get the output layer. Okay, output layer we will get. So this is also a hidden layer. So you can add many hidden layer as possible. Okay, because the output value will be good. If we add more hidden layer, then the output value will be good, because it will go through multiple calculations. This hidden layer will give some value. This, after getting that those value, we will put it through another hidden layer. So it will do another calculation. So finally we'll get some output. Okay. Okay, so from this output, okay, if we use sigmoid function, we will get value like 0 0.6, 0 0.8, 0 0.9, this type of values. Okay, if we use like say this one, okay, this one, then we'll get a output like 1 or 0. So basically 1 or 0. So basically final output will be 1 and 0. So basically what we will understand from this output 1 and 0. So if this is called voting. Okay, what is the maximum occurrence? One is the occurrence is the max. Okay, so let's say if the pass and fail result we will calculating from some input data. So one means pass, then we will know that two students will pass, and if we get zero, then one student will fail. So basically, it's the simplified way of telling whether this input will give what kind of result. Okay, so either 1 or 0. So let's say in here only 3 cases are there. There might be more cases. Okay, well, let's say 1 1 1 0 0. So in here, which will be the greater value? So 3 units of 1 is there and 2 units of 0 is there. So 1 is the majority. Okay, so this kind of logic we use in neural networks to decide whether from the input data that we need to calculate the output value. Whether, let's say, if we take some input data like study hours, this type of things, okay, these are the inputs we are taking. So finally we need to find out whether the student will pass or not. So basically, if greater values of 1 will come, then we will consider that these students have the high probability of passing the examination. If 0 comes more, then we will tell that this batch of students have less probability of passing the examination. So this is a way of calculating this input data. So why we using this neural network? Okay, so in machine learning, so if the data are more, so it will be difficult to calculate. Okay, it will be difficult to calculate. That's why we are using a complex network like a human brain to find out the output. Okay, so that's why we are implementing neural network. Okay, so basically this is inside the machine learning, but just for the sake of a large data set, so we are implementing neural network. Okay, so that's why we use neural network. If someone asks, okay, so this is feed for this network is called feed forward network. So I did not tell you the name. This is feed forward network. So why we call this is a feed forward network? So this is only going in one direction. Only one direction it is going. Okay. So it does not come back to this neuron. From this neuron, it will not come back to the previous input node. Okay. But in our brain, let's say if from we have two neurons, okay, if we sending a data from one neuron to another, so it might again come back to the other neuron also, but in this case we are considering the simplest type of network, okay, feed forward network. So that means it will go only in one direction, it will not come back. Okay, it will not come back, but this is the simplest way. Okay, but our human brain is not like this. Okay, because in our human brain, from one neuron to another neuron, the data might pass. Okay, so let's say 1 2, this is the number one neuron, number two neuron. So from 1 to 2 data transfer is possible, and from 2 to 1 that is also possible. Okay, so that type of neural network will called as a feedback network. Feedback network. Okay, so it's a more complex one. This is more complex network. Okay, so one type is recurrent neural network. Okay, recurrent neural network. Okay, one type is back propagation neural network. Okay, these are type of neural network that will use feedback. Feedback means, let's say if we go from this to this, okay, this is input layer, this is output layer, sorry, this is hidden layer, and this is will be the output layer. Output layer. Okay, so if the data is going in this direction, it might also maybe the reverse order is also possible. Okay, so it's a bit more complex one. Okay, hidden. Okay, so basically it will allow some loops. Allow loops. Loops means this is a kind of a loop. Okay, from 1 it is going to 2 from 1, so it will allow loops and feedback. Then feedback. So why it is feedback call? So basically, if I am let's say I am doing a class, okay, so you will get some uh, let's say you understand my uh, this course or not. Okay, maybe they will you will give a feedback that I did not understand sir's this lecture. Okay, but some of you might have understand my lecture. Okay, so this is the feedback you are giving. So our direction is like I am giving the knowledge to you. Okay, so I am the teacher. Okay, I am the teacher, you are the student. Okay, okay. So if I give you only the this, let's say if I only give you the information, okay, I will not will listen your question or anything. Okay, I will not reply it to you. Okay, if you have any question, let's say you are putting some you are asking some question, then I will not just bother about that. Okay, so that is one direction. Okay, that is like one direction connection. But if you give me some feedback, okay, so if you stop me, let's say I am not listening to you, your microphone is off or something like that, or I am not able to get this concept, just like this concept, you are giving some feedback. Okay, so basically that same thing will happen with our neural network. Okay, so if we give the input, so the output might also tell go back to the input neuron. Okay, so it's a bit more complex one. Okay, so that is called this is called recurrent neural network. Okay, this is a bit difficult. Okay, so in the next class, I will show you to implement this deep learning techniques. Deep learning, or you can call this as a neural network. Okay, so I will not go deep into the neural network chapter. Okay, I think it is not in our syllabus, but for the uh, actually you have to know about this neural network. So I am just giving you a brief introduction to this neural network and deep learning. Okay, so in the next class I will try to give you some notebook. Okay, notebook for practice this. Okay, notebook, and I will give you an assignment in the next class. Okay, assignment. Okay, so this is your this will be your final assignment. Okay, so in that next class, let's say Monday I will take, so we will both Monday or let's say Tuesday we can give, so we will send you the assignment. Okay, so it will, let's say the assignment will consist uh, we are not dividing it. Okay, but assignment will consist of like 30 marks. Okay, the final exam will consist of 60 marks, or maybe 2080 might be also happen. Okay, that we'll see. So you need to submit this assignment. Okay, so assignment. So some of the questions I have, I think, put it in the as a assignment. So I will make it as a whole. Okay, I will give you the Word file of the assignment. So what you need to do, so you need to do the assignment in white paper. Okay, white paper. So you need to make the PDF of that. Okay, PDF of that. So how to make PDF? So you can use any software, Adobe Scan, any kind of software you can use. Okay, after making the PDF, you just need to send your PDFs to Skillnist. Okay, by mentioning your name and all these things, all your details. Okay, so I will tell you the last date of submission. Okay, last date of submission. So after last date of submission, we will not accept any this assignment. So then you will get marks of 0. Okay, so if you submit on time, then you will get the marks around 20, maybe 30. Okay, that we will see. Okay, so if you get a good mark in assignment, then it will be easy for you to pass in the examination. Okay, so that's why I suggest you to properly do the assignment. The assignment will be very easy, so we'll give from our class only. You can use anything, okay, no problem, but please submit it on time. Okay, let's say if I tell you the submission date is 25 December, you need to submit before 25 December 11:59 p.m. Okay, so I will tell you the final date. Okay, but on that date, let's consider we are giving it as a 25 December, but you need to submit before 25 December. Okay, so thank you. So after submission of the assignment, we will take a examination like in 10 or 15 days. Okay, minimum 10 days after submission of, let's say if we submit assignment will give 20 December, then your examination will be 30 December or something like that. I will not put it 30 December. 30 December you will be busy. 30, 31st, 1st January we will not put it. We'll put it some weekend. Okay, we will put it like Sunday or Saturday. So all of you can attend the examination. Okay, so probably I will put it in a Sunday. So in the next class, we will discuss about the exam date. Okay. So if you are comfortable, you can give it in December in a weekend. Okay. Okay. Is there any question? Okay. Okay. Next class, I will say. Yes. Tell me.
Hello. Good evening, sir.
Yes. Tell
So,
me.
what will be the questions for the assignment?
Assignment question will be from your. Let's say I have done some summation. Some I have given you. So those kind of similar question will be there. Okay. So it will be very easy. You will get it will be not difficult. So it will consist of some sum and some objective type question. Also MCQ will be there. Okay.
Okay,
So
sir. Thank you.
you, okay. Okay. Thank you then. Okay.